very good morning to you all. Sorry, my system had
Good morning.
Do you have any questions among the items we covered before I can introduce mine? I told you to visit Backhouse 1 for numbers to try out. As a reminder, as a review of the factor theorem, this is still factor theorem. We can have an example which says x minus 1 and x plus 1 are factors of the expression x cubed plus ax squared plus bx plus c, and it leaves a remainder of 12 when divided by x minus 2. Find the values of a, b, and c. Now, to start with, identify our function f of x. Our function is x cubed plus ax squared plus bx plus c. Now, if the other ones are factors, it means when you substitute them, the remainder is 0. So if I substitute, if x is equal to 1 because of x minus 1 equating it to 0, then the remainder when x is 1 should be giving us what? 0. Therefore, f of 1 will be 1 plus a plus b plus c. It gives us the remainder of 1, which is giving us what? 0. Therefore, a plus b plus c is equal to -1, equation 1. Then the second one, the second factor is x plus 1. If you equate it to 0, you get x is equal to -1. Because it's also a factor, it means the function f of -1 is equal to the remainder of -1, which is also going to be 0. So therefore, what is f of -1? It will be -1 plus a minus b plus c is equal to 0. With this, a minus b plus c is equal to 1. Equation 2. Now, this last one is not a factor, so it has a remainder. So when I equate x minus 2 to 0, I get x is 2. So the remainder when x is 2, this is the remainder when x is 2, is going to be 12. Now the function when x is 2 is supposed to give us the remainder when x is 2, which remainder is what? 12. So for that reason, when I substitute x is 2, I'll get 8 plus 4a plus 2b plus c is supposed to give us the remainder when x is 2, which remainder is 12. Therefore, 4a plus 2b plus a c is equal to 4, and this is equation 3. So any question before I can go for solving the equations, because that's where the definition stops for factor theorem. What is left is algebra. Now, algebra we can eliminate. Maybe we can eliminate C, we can eliminate B, whatever the situation. For example, I can add Roman 1 to Roman 2. When I add 1 to 2, I'll have a plus b plus c is equal to -1. Add it on 2, a minus b plus c is equal to 1. When you add these two, check what you realize. 2a plus 2c is equal to 0. You see that A is equal to negative C. Okay. Then I can also eliminate, and I use Roman 3 minus twice of Roman 1. This will be 4A plus 2B plus C is equal to 4. I'm eliminating twice of Roman 1, 2A plus 2B plus 2C is equal to negative 2. When you subtract, we get 2A plus 0 minus C is equal to 6. So 2A minus C is 6 is the new equation, star 2, if this is my star 1. Now, because A is equal to negative C, I'll have a negative 2C minus C is 6. C will give me a negative 2. If C is a negative 2, consequently A is a positive 2. If A is a positive 2, then I'll have 2 minus B minus 2 is equal to 1. From which the 2, B is equal to negative 1. Therefore, A is 2, comma, B is negative 1, comma, C is negative 2, hashtag solution. So that is what we discussed last week. Please repeat. Sorry, yeah, these first numbers are always reactivating us of what we stopped at. But in case you have a question, please raise it. So Swale, where is your concern? Because I'm assuming you tried out some of these numbers of this category, so I'm just reviewing. Where? Swale. Swale, where are you? Swale is not here. I saw his chat saying, hey teacher, I think you left me somewhere. So the definition is 1. When you substitute the value of x from the divisor, these are the divisors. Yeah. When you substitute the value of x from the divisors, then that value of x should give you the remainder. If the function, if the divisor is a factor, the remainder is 0. If there is a remainder like the 12, and the divisor was x minus 2, then we equate x minus 2 to 0, we get x is 2. When you substitute x is 2, you can be in position to confirm that the remainder is 12 when you substitute in the function. So basically, that's the definition. Unless if someone has a question other than that one. So Swale, I don't know whether I've helped you when I've mentioned such information. Okay, so if no question, let me give another example.
I have a question.
Go ahead.
Please go back to that. That's my question.
Pardon?
Here, where we got f of negative 1 is equal to negative 1 plus a minus b plus c. How did you know it is minus b?
Yeah. And now, this is our function. You see our function? Okay. Where is x, we put negative 1. When you put negative 1 on x cubed, what do you get? Don't you get negative 1?
Negative 1, yes.
Now put it on a, x squared. When you put negative 1, what do you get? Negative 1 squared gives you a positive, not? Yeah?
Yes.
A, so you square the positive. It gives you a positive a. Now the b and the x, singular x, remember is negative 1. So when you substitute x is -1, you get a minus b. Is that
Okay,
clear?
thank you.
You're welcome.
Yes.
Okay.
So what about the next step?
What about the next? The next step, eh?
The one of f2, function of 2.
Okay. Now the function of 2, the divisor is x minus 2. You equate the divisor to what? To 0 and get the value of x. That's how I got this 2. It means that if I substitute in the function this one and I put there 2, I must get the remainder when x is 2, because I told you sometimes the remainder can be in terms of x. So to get it, you equate the value of x when you have the divisor. Now, the remainder when x is 2 is 12. But when you substitute that value of x is 2 in the function, it should give you the remainder. Now, if you're to see this number, for example, check this one out. If you're to see this function, if I write the values as given, it is x cubed plus 2x minus x minus 2. If I put in -1, check, I'll get, I've told you when you put the value of the divisor, if it's a factor, it gives you 0. If I put -1, let us confirm, do I get 0? 1 plus 2 minus 1 minus 2. You see that I get 0? So that's where the knowledge I can